Hello, everybody, welcome to our talk. It's a big crowd here and remotely, and also in the other room where it will be also live streamed. So I would like to welcome Fabian and Lukas, who will present today. Fabian earned his doctorate in mathematics and is a senior consultant at TNG. And Lukas started his career more than 10 years ago in web development and is now a principal consultant at TNG. Both are experts on cloud systems and DevOps, and now they will tell us about 99 ways how we can set up our applications with infrastructure as code.
Danke. Thanks, Patrick. Okay, thanks again for joining us in our today's call. Also, thanks to all the people remote and nearshore, not sure how it's called. So it's about 99 ways to set up your application with infrastructure as code. And I need to break the ice here. It's not 99 at the end, so please, I'm sorry. All right, so why are we talking about it? We already got introduced and we were working on cloud topics, DevOps topics, and so on. And while working on this, we worked on a lot of infrastructure as code topics. And this is why we want to highlight the motivation for today's talk and also for the topic in general. So what we think is that infrastructure is evolving over time continuously. Meaning, it's like yesterday I was asked, what kind of infrastructure? For sure, it's like in software development. And what it was before is like single servers. You had only small systems, small servers, then you had multiple servers, and then at the end, or right now, we have rooms full of servers, data centers, quite huge, and the way how we use it also changed. Previously, it was just fixed systems, and you had an application running on a server, or maybe twice, 2 applications, 3 applications, 1 server, or load balance, and so on. And what we have today is we have a way more flexible infrastructure. Meaning we have way more requirements also to the infrastructure. Also, what changed is in the past we had operation teams, while nowadays we more likely have DevOps. Okay. We don't have audio in the other room.
Du musst lauter schreien.
Yeah, we need to talk louder. Okay. So I give you all the insights. Those guys over there will not notice. We used Midjourney to create all these wonderful pictures, and hopefully they are not too distracting. Okay, thanks. Right, so infrastructure is continuously evolving, and software requires infrastructure. And what do? Well, we are consultants, but still we are software developers, and software developers develop software. So the question which pops up in our head is, how is infrastructure developed?
Yeah, and that's when I take over. So to answer this question, we would like to give some brief historical throwback here, and we go back into the year 1993, and that was the year some game-changing piece of product was released, which was the following, and I don't know how many recognize this, but this is the logo of the Mosaic browser. And so 1993 is for some supposed to be the start of the internet as we know it today. However, in the same year, these lines of code became meaningful because they belong to the tool CF Engine, and that is supposed to be the first infrastructure as code tool on the market. And so maybe, I don't know, but maybe we're looking at the first infrastructure as code lines ever written, which are there to give some test file on some server the right file permissions. So this is how it all started. And of course, the internet was a game changer because suddenly there was the need also to equally configure web servers all the time, which are of course not identical, but should be equally work. And at the same time, what started is the era of virtualizations, and you were suddenly able to deploy virtual machines on and off all the time. So a few years after that, the cloud providers, as we know in the day, took off. AWS started its business in 2000, then Google Cloud Platform and Azure followed 2008 and 2009. Around 2006, AWS started its famous EC2 service to deploy virtual machines in the cloud. And also in this context of infrastructure as code, 2005, Git was released, so the today most famous version control system. And following CF Engine, at the same time, new tools came to the market to configure infrastructure as Puppet 5 and Chef 2008. And then things continued, of course, quite fast. So after this age of the internet has started, the next age was the age of the cloud and the age of containerization. So 2013, Docker came on the market. 2000, I can do this, can I? No.
You need to move to the left.
Oh, that's fancy. Oh, that's fancy. Yeah. 2014, Kubernetes, so soon after, was released. And we see at the bottom part here, with that time also a bunch of new infrastructure as code tools came to the market. So there were tools like, I do like this, SaltStack or Ansible, following the style more of Puppet and Chef. And then also the cloud providers themselves released their own tooling, starting with AWS CloudFormation in 2011. AWS also released then later on the AWS CDK in 2018. Azure and Google also released their own tools to configure infrastructure as code. Very notably, Terraform was released 2014, which is maybe one of the most influential infrastructure as code tools on the market. And that style, also interesting to know, is Pulumi 2017. And a very powerful tool, which we'll have a look close later on, is Crossplane in 2018. So that just to give you like the historical background and how things evolved over time. Of course, we have not yet really spoken about what actually infrastructure as code is, what it means. So we would like to do so by telling you about the 4 key principles, which first is to define. Sorry.
Ja.
Hast du gepult nochmal?
Wann hast du gepusht?
Gestern Abend.
Gestern Abend.
Kann man das noch kurz?
Ja, klar. Warte.
Gut. Okay, maybe it's a good thing because the room next door is all. Okay, there. Yeah.
It takes a second.
Yeah, well, do you have some more? What?
It will be eventually consistent.
Yeah, eventually
Oh, yeah.
consistent.
Nice. That was quick.
Right, it was
such a
fast.
quick. Like, how did you do that so fast? And actually, where are we running those slides?
Thanks for asking. I will take over now. So let's talk first about how we run the slides before we talk about the principles. So now we are at home, at my home, in my basement, and I have a Raspberry running there. It's behind a Wi-Fi router, and this is where the slides run. I pretend to. But actually, that's not all what we want to tell you. We want to tell you about Chef. So Chef is one of the first tools which can be used to connect to an instance and also which run on systems. And what systems? It's like Linux kinds of systems usually, and you can connect to them and just configure it. Meaning you can ensure certain packages are installed, services are running, and files exist, such as these slides. This being said, let's have a look a little bit closer into Chef. So Chef was introduced 2009 and did some progress because nowadays it's called Progress Chef, and it is meant to be a management and deployment tool for infrastructure and applications. And originally it was on-premise, but the progress they did is that they now also adjust to or adapt to cloud platforms such as AWS. How can you use it? You use declarative DSL files, and those are like you write your own recipes, then you combine them together with cookbooks, and then Chef applies it, right? And since lunch is soon, we need to skip this topic about the cookbooks and the recipes. And right, so this is what we use is more like a solo mode, but you can also use it in a server client mode. And behind this slide deck, we have like this. In the beginning, we say we need to have Apache 2 installed. And underneath, we say we also need to have some configurations for like SSL. And then we have the most important part where we define how the default Apache 2 site, so Apache 2 is like this famous HTTP server where no one is talking about today. And yeah, this is where the presentation runs. Right, with this being said, I think we can continue again, move the mouse outside. Not working.
Not working? Okay, thanks, that was surprising. 4 key principles, which are we define everything as code, we treat everything as code, we test everything as code, and we deploy everything as code. Let's start at the beginning. If we say we define everything as code, this should mean that nothing, really nothing that is running in your cloud environment should be manually configured. Instead, everything should go back to some lines of code. What comes with it is that when you develop things in code, you also structure them as code, so you get out of the box a modularization into stacks of your infrastructure. And also you follow the dry principle, meaning the don't repeat yourself principle. So of course you would never copy-paste lines of code. Instead you parameterize them and you are able to redeploy similar flavors of infrastructure multiple times using the same lines of code. The benefits from doing so are that you gain transparency. The code serves as the source of truth for your infrastructure, and all the time you can know who deployed something, when what is deployed, and what is deployed in infrastructure. Also with that, you almost out of the box get a documentation of your infrastructure, because if you have well-written infrastructure code, this can serve as a readable documentation of everything that is deployed in your cloud, for example. And you gain reproducibility. So as I said, you structure your code, you parameterize it, and then it should be easy for you to redeploy things, for example, in different environments, such as a production area or a staging area. Right, so I talked about the definition of code. How do we treat the engineering process?
Right, thanks for asking. So it's like, the question is how do we treat it? And we treat it as code. So as we would treat, or as we actually treat, or should actually treat software application code. Meaning, we put everything inside version control systems. So everything related to infrastructure is now code, and this code is part of, for example, Git. And this enables us to establish, for example, review processes, which should be quite common also for to have the 4 eyes principle at least. And also, it can enable you to utilize patterns, same patterns as you would have established with programming and in the software itself. And yeah, this goes hand in hand with also code style. So now that you have the possibility to describe code, you need to follow a certain kind of style. Eventually, this ensures the quality, and it can establish best practices, especially in bigger teams. So this also enables collaboration. So one is maybe not too experienced, but they know I want to have a second instance of something I'm aware of, so they can simply create this pull request. And at the end, it should also increase the efficiency. Talking about the increase of efficiency, at TNG we always say, don't believe it, test it. And Fabian, how do we test it?
Test everything as code. Exactly. So next principle, if you do something in code, you should test it. And admittedly, testing infrastructure code is a very challenging topic, but it is possible at least to some extent always. Meaning this starts with a standard static code checks, you can have formatting checks, you can have linters running on infrastructure code, but then you can also go from unit tests that just test small substacks of infrastructure up to really full system tests that test the full deployment. And if you do this consequently, which is a hard thing to do admittedly, you can even do something like a test-driven development style here. It is challenging, it is demanding, but it comes with some nice benefits. If you have really well-tested code, if it's well-testable, this actually implies that you have well-structured code, because in order to actually be able to run certain unit tests on your substacks, you must have defined substacks properly in a way that you can test them independently. Also, of course, if you have tests, what you gain from that is prediction. And hopefully your results of your deployments become so predictive that you allow yourself to run those in a continuous deployment environment automatically. How would that work, Lucas?
Right. So from one cat, we like cats, so we need to have multiple cats. We want to have a bunch of them. And how can we achieve this, right? And it's the same as with software. When you have tests and you want to have CI/CD, continuous integration, continuous deliveries, continuous deployment, and also continuous tests. And we think it's best if it's even automated, meaning that when you change something and you merge it, then it should be automatically applied to the respective stage. Also, you should always utilize smaller changes, being agile. So instead of having huge infrastructure changes, try to always have minor, smaller, simple changes. And it's similar benefits here. So at the end, it's reliable and you have a documented process. You can avoid human failures. Just happened to us yesterday, right? The one part we did not define with infrastructure as code for our slides did fail. We should really avoid this, especially in production environments. And also, like agile development, you should also focus on agile infrastructure development. And while being able to implement small and simple changes, this should easily be possible. With this being said, we also have some common challenges prepared. And yeah, so let's continue.
Lucas,
Yeah.
I have a tiny proposal here.
What?
How about we do not run this thing in your basement, but properly in the cloud? Would that be fine for you?
Okay, yeah.
Okay, let me link here. I prepared something for this case.
Nice.
Let's move to the cloud, guys.
What did you do actually, Fabian?
Nice that you're asking. Thanks. Have a seat. Yeah, let's evolve as infrastructure evolved over time. Let's also evolve over time. This presentation. Yeah, we deployed this thing now in a very classic stack into the cloud. Nothing fancy. Really a classic thing to do. Meaning, our presentation are running on a virtual machine in AWS, meaning an EC2 instance. Of course, when you then go this way, you also would also like to have all the other nice features in cloud, such that a HTTPS encryption, of course, meaning you need some other stuff. You need to put the whole thing in some virtual network, of course. Then you need some Route 53, which is a DNS entry in AWS. You need a certificate manager. You need to define roles in order that the parts can communicate to each other. You need to set up security groups. Some stuff needs to be done, and already so much stuff that you would not want to, and you should not do this manually. Instead, of course, you use some nice stack of tooling. What we did here is we used a stack of two technologies. We used Terraform, the industry standard, to provision all the resources you see here on the right-hand side. And then we downstream triggered from there Ansible to do what?
Right, so we downstream then Ansible, meaning that Terraform, when the EC2 instance is deployed, will run Ansible or will trigger Ansible playbook, actually in this case, for this presentation, where it's really actually running right now in AWS, in the TNG playground. So please, all the colleagues, don't fool with us right now. Yeah. And what it does, it ensures, it connects to the instance, and then it ensures that files are uploaded and exist in the way how we define them, and also that certain software and applications are installed. So let's have a closer look into Terraform first.
Yeah, so Terraform, one of the most influential tools on the market, allows you to provision and manage any kind of cloud resources. It's generic, works for channel providers. Basically, any provider that offers you an API to deploy infrastructure, you could write your own Terraform provider in Go. But of course, for the typical use cases, AWS, Azure, Google Cloud Platform, providers are already existing. Terraform ships with its own domain-specific language called the HashiCorp configuration language. And of course, this is something to learn when you start working with Terraform, but it is fairly easy to learn, and it's a very readable language. So Terraform is a so-called descriptive infrastructure as code tool. This means that you do not have a lot of imperative things you can do. There's only a very limited support of conditions or loops and that kind of stuff. But what you gain from that is very simple and readable code by just writing down what you want, and you get it deployed. Terraform allows you to structure your infrastructure in so-called modules. And then there's one thing with basically all these tools which they have to solve somehow, which is how can a tool remember what has been deployed to the infrastructure online and what is defined in your code. Meaning there needs to be some synchronized connection between the actual running live environment and your local configuration of it. And what Terraform does here is it has its state file, which might be a pro or con for Terraform, depending how you view it. And you can either store it locally on your machine, maybe not the best idea, or also in some cloud-based stack. Let's look at a quick example on Terraform. So this is the code we used here to deploy this virtual machine where these slides are running. Nothing fancy and very readable. So basically, you just tell Terraform what you like to have. So in this case, you say, I would like to have a AWS instance. This is an EC2 instance. Give it some name. And then you just list all the parameters you would like to have. For example, we say, OK, the instance type should be T2 micro. And so you just say what you want. And this is actually a good documentation of what our virtual machine looks like. And what you can also then do are things like here define a so-called provisioner, which basically says, OK, Terraform, whenever you have then deployed my virtual machine, please call my Ansible playbook to do other fancy things. Lucas, what are those?
Right, so Ansible. What Ansible does is similar to Chef, but not comparable. So what it is a configuration management service, and it can be applied across multiple systems, meaning different host files, and can be virtual machines, actual machines. It depends. And what it does in the end is it ensures that the desired state exists. So you describe how the virtual machine should look like, how the instance should look like, and Ansible will make sure that it's in this state at the end. Also, it's quite valuable that you can apply this to any kind of virtual machine, so there's no need to instantiate your application with Ansible first. You can just, like, at any point in time, apply it. And how can you do this? So first, we have these YAML file structures, YAML files, and then it's a module-based architecture. And the three main components are playbooks, roles, and inventories. In inventories, we have, like, the list of the different hosts, so it's a lists of hosts, and then we can apply the playbooks on those different host lists. One thing which is quite valuable is that it's easily extendable, meaning if you work with Ansible and then predefined Ansible module, you will come to the moment that it's, like, not fulfilling your requirements, and then you can easily just implement in Python your own module for that. So for this slide deck, we connect to the web server, to the host in the key web servers. Then we become root, and we make sure Nginx is installed, it's running, and it's configured properly. Right, with this being said, let's continue with the common challenges.
So yeah, we already talked about, we mentioned challenges already, such as testing. Testing infrastructure is very different from testing usual code, mainly because it is really hard, if not even sometimes impossible, to predict the outcome of a deployment without actually deploying it in an online environment. So what changes here is that when you usually look at the structure of your code test, you have this pyramid in your mind, which has this bigger part of unit tests at the bottom, then less integration tests, and then only a few system tests. This looks different for infrastructure tests, and some people talk here about the so-called test diamond. What you do here is you have a basis of offline tests meaning nothing that actually calls your cloud provider's API. What you can do there are those static code analysis I mentioned, but also what you can do here is use mocks of your cloud provider in order to then locally test your infrastructure code. Then what should be the greater part are the stack tests, meaning you try to deploy your substacks of infrastructure in an independent environment, separate from each other. And then, of course, the system tests, which can range really from full end-to-end tests where you deploy the full infrastructure every time, or you may have, for cost reasons, just a permanent deployment of this infrastructure. You run updates and then just test that the changes have been applied successfully. This is challenging. Fortunately, there are a bunch of tools on the market that support you with that, of very different style. You have tools for Terraform to support you with security dependency management. Tools from AWS like the CDK or AWS serverless application model come with tools like for unit tests or for local mocking of the AWS API. For AWS, very important to mention is local stack, which also is a full offline mock of basically the whole AWS service API. And finally, we would like to point out TerraTest. So TerraTest, from the name, originally developed for Terraform, is actually a general framework in Go, a Go library that allows you to test the typical life cycle of an infrastructure deployment. And this life cycle means first you need, of course, to apply, to deploy your infrastructure. Then you would like to test against this infrastructure. And then, very important not to be forgotten, because you work against an online API, you will need to destruct your infrastructure again. Here's a small example how this looks like in TerraTest. So it's a Go library. So this is a Go function. It uses the standard Go testing library, and then has some helper functions directly called Terraform from within your Go code. And we see here these three famous parts. So at this line, we say init and apply, which basically says, Terraform, please deploy my infrastructure. Then we get some tooling here. Is it online? So in this case, we have a web application running. So we do some HTTP GET request, and we expect that a 200 comes back from that, and then we are satisfied. And in any case, this defer keyword here, we would like to make sure that in the end, it's destroyed again. And so everything is cleaned up nicely, and we don't have like zombies of test stacks floating around in our infrastructure. This was the first of many, many challenges.
Right, so we wanted to point out one more challenge. It's the configuration drift. In this building, it might be like misunderstood. I think for this crowd not, so it's not about drifting with cars, it's about the configuration drifts in terms of something changed. So for example, you configured something, but it's not the actual state anymore. So we already talked about the Terraform state file and so on. And yeah, so this is what we want to talk about now.
Ooh, well, that should not be.
You also know what should not be?
What should not be, Lucas?
Running your damn application in a virtual machine with like Nginx.
Yeah, but it had to be simple, right?
You know what is simple?
No.
Running your own EKS Kubernetes cluster with just a few lines of code.
Ah, you're kidding me.
I'm showing you. Here we go.
Seriously?
Yeah, that was it.
Is it?
Yeah, it is. Is it?
I don't know. Is it? Ah, it is. Yeah.
It is, right. So this is our third stack we want to highlight. And it's actually running in a Kubernetes cluster, which we need to shut down right after this presentation. Because it contains all the... never mind. So what we have is, we have a Kubernetes cluster in the same AWS account in a similar VPC as before. And what it does is it runs the application. And the application is accessible from the outside via AWS DNS, which is Route 53. And then it's more or less the same as in the previous stack, where we had this application load balancer, then like forwarding the traffic to the application. The application itself is like hosted on code commit, then the code pipeline builds the application and uploads it to an image registry. And the Kubernetes cluster can access this and download the application where needed. So this is even more complex as we had before. I'm sorry. And so let's have a look into how we actually did this. And this is the moment where we want to introduce two tools, CDK, AWS CDK, and Helm.
Right,
Brian.
thank you. Yeah, very impressive stuff. So you noticed we started from the basement of Lucas over the classic virtual machine, and now we are the full EKS Kubernetes cluster, and things grow in size rapidly. And if you have such a complex structure, you need, of course, a coding tool which is so high level that it supports you to be able actually to deploy this kind of infrastructure nicely. And this is exactly where now AWS CDK comes into play. So again, we use this tool to provision all these things you see on the right-hand side as they are depicted there. And how this is possible is that CDK comes with really nicely bundled components out of the box and gives you a lot of opinionated defaults for them, so that you just have to say, okay, what are your special needs then? Just with a few extra lines, so you say, okay, I would like to have this flavor here, this flavor there, but everything else more or less comes out of the box. This is how we deployed the EKS cluster. Then, of course, we have a nice cluster, but no app running.
Right.
What do we do there?
So when you need to if you want to deploy an app, especially like a static application, it should be easy. And what is easy is Helm. It's easy to use, sometimes more complicated to use. But in this case, it was easy because we were using a predefined Helm chart, and this helped us to deploy and version the application. Meaning, by this, we can reduce the essential parameters to a very low minimum. But this depends on how Helm is configured and which kind of chart you can use. And since we talked already about charts and details, let's go into the details of CDK first.
Nice. Oops. Okay, so CDK is the AWS Cloud Development Kit. So it's an AWS-specific tooling to provision any kind of resources in AWS. And what is different there from Terraform as before, it is a so-called bring your own language tool. This means you can write your code there in JavaScript, TypeScript, Python, Go, whatever you like, basically. And what also is implied by this, that it's an imperative tooling, meaning now we have the full power of this programming language in the background. What actually does it generates in the end a so-called CloudFormation stack, which is a rather infamous tool of AWS from 2011. And what you gain from that is a bunch of reusable code, because basically you can do all your programming skills, apply them there, and develop classes, libraries of your substacks. And you gain, to some degree, also a testability, because CDK ships its own assertion library, and you can do, at least to some extent, do some offline unit testing here. So Lucas claimed only a few lines of code are necessary to deploy a full EKS stack, and this is the truth, actually. Not everything is the truth, maybe with the stacks, but this is actually the truth, and this is running right now on our playground. And yeah, those are all the lines, and this is amazing from my point of view, that you need to deploy a full EKS cluster. Okay, small lies, you need to give something like a VPC also to have some network. Yeah, some essentials are missing, but that's not it. So you just say, this is TypeScript. So what you do is you define your own class that extends a standard CDK class. And then in the constructor, you just say, okay, give me a new instance of an object, of a cluster class, which is also coming from the CDK. And then again, as in Terraform, you just say, okay, what are the flavors I would like to have? And here these opinion defaults come into play. So some things you do not get around, you need to provision this VPC. But then things like an application load balancer, which is really something otherwise a lot of work to do. You can do things, of course, with Helm to do this, but then still you have some effort. And here it's really just saying, you know what, I would like to have this load balancer. Just here, this version, just do it for me. And it does out of the box. And this is really a really fancy, magical thing to do. Right, what about Helm?
Talking about fancy things, Helm is also quite fancy. It was introduced 2015 and is part of the CNCF since 2018. CNCF is like this collaboration, this organization around Kubernetes, so it's quite promising. What it does is, it is a package manager for Kubernetes resources, so whatever you define in Kubernetes, you can define as a package in Helm. And this whatever is usually like configuration and the deployment of the application itself. Depending on the cluster, so in our case EKS, it can also help you and enables you to provision AWS resources, such as ALB or something like that. Similar to the tool before, it's like it uses YAML files, and it is actually, because YAML files can get long, it is parameterized and it's using templating, especially the Go language templating, which when one is used to it, it's quite great. These charts are then packaged as versioned charts, and then when you release it, they are also versioned, right? So we have like similar things as with the version control systems. For sake of this presentation, we did utilize an existing chart, and we only needed to provide values. So this is the set of values we provided to our Helm chart. It's a rather small example, because having a look into the whole Helm chart would be way too much like an own talk. And right, so we defined that one image should be used in some deployment, and then the most important part for the application here, how we can access it, how we can route the traffic to the application. Okay, so with this being said, we can go back to the configuration drift.
Go ahead.
Go ahead, right. So, when talking about configuration drift, we need to have a look again to our cat. So previously it was like super nice RoboCat, and it was a bunch of RoboCats, and now it's like maniac RoboCat, because it drifted away. And this is what we need to be aware of and what we need to face. So we state, once deployed, infrastructure drifts away. And we think that this is because these tools we just talked about and all the others, they are blind to certain things. So they are blind to manual changes, manual fixes, and manual deployments. Manual updates. They are blind to changes by other tools or changes by the provider or by dying components. Meaning if like there's an incident and someone needs to do something or the provider needs to change something, it might not be reflected. And at the end, it could be that like the next time you run the change, it pretends to run, especially with Terraform, the state looks fine, so it pretends to run, and then when you execute it, it will fail because something is not existing or is already changed, and it's like a total mess. How can one prevent this? So there are a few also principles, I would call them, in order to prevent it. And it's like promoting the infrastructure as code culture. No manual changes. And also, for everything you define as code, automate the continuous deployment. There should not be like, it's in master, but it's not in production. It should not happen. Just make sure that everything which is defined as code is also reflected in the infrastructure. And one way also to achieve this maybe is to make the infrastructure immutable, at least for manual changes. So you as a developer, you as like the business owner, you are not allowed to change it because only like the tool is allowed to do that. Right, so this leads us to the question, is there the perfect infrastructure as code tool? And for those who have like paid close attention to the beginning, to the timeline, there is one we did not talk about yet. And I want to give it highlight it here real quick. It's not the perfect tool, I can say already, but it's something which allows manual changes. It like reverts them or it propagates them. It allows to import existing instances. And also, it's in the Kubernetes context, so it's cross-plane. Maybe you have heard of it before. I know a few in the room. They have been working together with me on this topic. And I think this is personally, it is a quite great tool, because what it does is it provisions any kind of resource with as a Kubernetes object. Any kind depends on the implementation of the provider. There are implementations available for AWS and Azure, and there is the possibility to implement your custom provider implementation. And what it enables you to do, and this is the major game changer compared to like tools such as Terraform and so on, it enables you to provide reasonable infrastructure templates. So you don't define it once, but you define a template of how the infrastructure should look like in a Kubernetes format. How is it done? The main important thing is the continuous reconciliation done by the control plane, which continuously compares the state of what you define in code and the actual state. So you can define how often it iterates. Yeah, we prepared a lot, but not for dying battery. But if you would have prepared for it, it would be a manual change. And here, in this case, manual changes can be done. And depending on the provider implementation, they are respected or they are reverted. And also with this, it can import existing resources. And there's one fun thing, actually, or maybe not fun. So if you have different implementations or different instances of a template, they can refer to the exact same instance at the end, and then they might fight each other for which one is the correct configuration. So this is a rather small example. Because of this rather complex topic, we did not put it underneath our slides, so you need to believe me when I say that this is a composite resource claim, a XRC, which is a part of the documentation of Crossplane, and this is how you can get a SQL instance in whatever provider is used underneath by the platform team. One thing which is quite valuable here is there is this write connection secret to ref, and this is the place where you get all the details like where can I connect to this instance, what is the username and password and so on. Right, and with this being said, I already said this. It's not the perfect tool, but let's share some opinions. So first of all, it's just another infrastructure as code tool. But it's a little bit more because it has it fits in the Kubernetes concept, and with this control plane and the YAML structure, it's quite valuable. It enables you to deploy an application in all its dependencies with one Helm chart, for example. So we had like this CDK stack in combination with the Helm chart, and we could also do it the other way around, that we have if a Kubernetes is running and you have Crossplane installed, you can create another EKS instance and then automatically, once it's provisioned, install the application also via Helm. So you have one place where everything is defined. But, and I framed it already, Kubernetes should already be there. So if you have one application, it's rather useless, depending on the load and so on of the features, to use Kubernetes. But now also introducing Crossplane instead of, for example, Terraform, which is rather easy to use, is, I would say, not recommended. And also, one of the features is this templating of the infrastructure. You should really utilize this. If you do not utilize it, it's rather not a big deal. So, the perfect infrastructure as code tool. Does it exist? For sure, but it depends, right? Okay, so Fabian.
Yeah, I think that was something, and I think also look at the time. Things evolved drastically over the last 30 years. We saw that. And what we also saw is, I think, that what evolved is the complexity. And the one thing that we wanted to give you with the talk was, of course, just a brief overview about the many, many tools on the market. And basic story is, of course, things change, things evolve, and you have to keep track. And in order to keep track with the complexity, the code tools that are developed on the bottom also have to keep up with those changes. And so we are in the year 2023, and Lucas, I'm really sorry we don't have any more time. We would have so many more stacks. I think we have now 4 of 99. We have done those. But yeah, we would like to thank you for the attention, for all the crowd coming here today. And yeah, thanks for being here with us.
Thank you very much, Lukas and Fabian, for this wild ride through the DevOps landscape and time. Please, for everybody watching the live stream, either in the other room or from remote, please join our Slack channel, Real Geisdorfer, to ask questions in Slack. And please, from the audience here in the room, please raise your hand and we have 5 more minutes for questions. At least.
The question I would like to hear is like, what's the next stack, right?
Yeah, I mean, you can also ask your own questions.
No.
Do you have an answer for that? What's coming next? Is Kubernetes the end of all things?
No, it's way too heavy. So, oh no. What we prepared is like a serverless stack.
Yeah, we could go on forever here.
Okay.
Right. No, seriously, no, we're finished. We're finished. We could talk, of course, about how to deploy a serverless stack. Then you could use AWS SAM for it. You could look at the details. You could look at some code. But I think people get tired. You get the message. I think you get the message here, right? Yeah. No, we're at the end. No, we're at the end.
Any questions in the room? Yes.
By the way, great talk. Many thanks for it. One question regarding the cross-plane. You talk about testing infrastructure before with Terraform, with Helm, with everything. Is possible also to test with code cross-plane infrastructure that you deploy with cross-plane inside of Kubernetes, inside of AWS clouds?
So what is always possible to use something like TerraTest, I think it's called, where you can connect to anything, and it's actually not a testing tool, but rather a tool which enables you to establish something and scale it down at the end again. So something like this is possible. Also with crossplane, it depends. There are many facets. What you develop, if you develop a Go provider in the backend, you can have unit tests over there. But if you want to test the full stack, I think it's rather useful to use some of those tools we showed you. To connect from the outside and just to observe it if it works like this. So the first thing I would try is TerraTest.
Yeah. I mean, a good thing with crossplane is that you can run your local Kubernetes cluster and run it locally to some extent. That's maybe a good thing there. But other than that, if you have a thing which is descriptive, as also crossplanes with its YAML files, you will need some testing tool like TerraTest, I would say. But I have not researched every tool on the market, so who knows what's up there. Yeah.
Maybe this is missing for the perfect infrastructure as code tool, right?
We have an expert in the room. Are there tests in our code?
What?
Okay, we don't want to hear the answer. Thanks for the question. Are there any more questions in the room?
We have one remote question from Nicolas Schwab, who's asking in our Slack channel, do you see Nix OS as infrastructure as code? Is there a place for it in professional deployments?
So this question leads towards the direction, what is the difference between infrastructure and configuration as code? And I think Nix OS is a great example of being both. So it's running on my personal machine, on my work computer, and what you can do with it is like a Linux operating system where you define your whole infrastructure, so your whole Linux with a configuration file, and you can also configure certain tools. So such as you can, for example, configure Git, so you don't need to have the Git files, but then you can also not change it. And in our case, we need to change them for some MFA reasons every day, so it's not feasible. But yeah, I think NixOS is actually a great infrastructure and configuration as code tool, which is rather complicated to learn, and this is also the reason why it's not too popular, I think.
Okay. Thank you for the response. And our final question from the room.
Hi, thanks. So in your your points on how to make infrastructure as code successful, one of the points was do not make manual changes. How does that coexist with, for example, an incident which affects your infrastructure?
Yeah, it depends, right? Maybe it's a solution for the problem in the incident. Maybe it makes just tomorrow's problem. You always need to.
One way to cope with that is to really have immutable infrastructure pieces, which means that you do not plan that things change, but if things are broken, you redeploy them as a whole. And so this kind of mindset then there could help that you say, okay, if something's really changed, I mean, in the Kubernetes cluster, well, this is how you would do it. You would just kill the pod and have a new one coming up. And I think, indeed, rather than saying, okay, I now log into my machine and do some manual stuff, which is then all floating around in your online environment, I would also rather go for this kind of mindset to say, okay, then just tear it down and have a new one coming up. And this should be then predictable. Yeah. Of course, if the world goes down, yeah, what to do?
Great, thanks for the great questions and for the interesting talk. It was amazing. It will be on YouTube afterwards, after the conference. So thanks, Fabian, and thanks for the great interest. And so the next step here at the conference is, of course, lunch. And everybody who's here in the rooms and also basically in the other room where it is live streamed, please stay upstairs. So directly going straight ahead. There's this Highline setup for lunch. And if you want to go outside, you can also go downstairs and outside to the beer garden. And yeah, that's it. Thank you very much.
Vielen Dank.
Thank you, Patrick. Thank you.